Beginning on page 26 of your textbook is section 1.4, which discusses rewriting formulas and equations. Sometimes we have linear equations and sometimes we have nonlinear equations, so we're going to be looking at a couple of examples of both and isolating the variables that we are looking for. So in our first example, we have a linear equation, which means it can be written in the form y equals mx plus b, alright, as previously defined. So that means I can isolate y, and I'm going to have some sort of slope times my variable x with an additional y-intercept piece added. So our directions are to solve for y, so that is part one. So in order to solve for y and isolate y, we want to go ahead and add or subtract any terms that we can first to the other side. So I want to subtract away x, that 9x, and I am left with negative 4y equals 7 minus 9x. You can already see how it's starting to look linear. And the last bit here, we have a negative 4 multiplied by that y, so I want to go ahead and divide each side by negative 4. When I do divide by negative 4, make sure that you divide both terms by negative 4. So I do end up with a y equals, and that is going to be a negative 7/4. I don't need a calculator for this section really, because we're leaving it as fractions, and a 9/4 x, a positive 9/4 x. If you feel like rearranging it into the slope-intercept form, that would be a good move so that you have some consistency. So a y equals 9/4 x minus 7/4. So that is part one. Part two says, we'll actually go ahead and find y when x equals negative 5. In order to solve for y when x equals negative 5, all we simply need to do is substitute. So I have y equals 9/4 times my now x, which equals negative 5 minus 7/4, and I multiply through. Remember, I can write negative 5 as negative 5 over 1, so I'm going to go ahead and do that so that you see y. Alright, so that I can multiply across, and I get negative 40 over 4 minus 7 over 4. Or sorry, that's negative 45, which gives me a grand total of a negative 52 divided by 4, which equals negative 13. Alright, so just confirming, when x equals negative 5, y equals negative 13. Okay, so there are two parts. We want to actually solve using variables where there's going to be a y and an x, and then when x does equal some value, we do want that y value. So please make sure you read your directions and complete both parts. Looking at another example, this is a nonlinear example. So the difference is y is no longer by itself and x is no longer by itself. They're being multiplied together, and that just gives us one additional step. So solve 2y plus xy equals 6 for y. So I still want to isolate my y. And one student actually suggested today, why don't I go ahead and put this side in parentheses. Now, that did not change a single thing. I haven't even really taken a step yet. But they suggested that because that way they could see, well, I can undistribute that y, or as I would say, we can factor out that y by undistributing the y to both of those terms. So I want all of my terms with y together on one side, and then I can undistribute it. I'm left with 2 plus x. So I'm left with y times a quantity equals 6. Well, how do I undo multiplication and move this term? I divide each side by 2 plus x. So that will cancel out, and I get y equals 6 over 2 plus x. And then very similarly, when find y when x equals -3, all we do is substitute in that value. 6 over 2 plus -3 equals 6 over -1, which is -6. Alright, if you all have any questions on these problems, please feel free to send me an email or see me before or after school. Good luck and happy solving for y.